Magnets and magnetism. Firstly, I want all of you guys to remember that when we talk about magnetic materials, we're talking about materials which are attracted to magnets. And the four that I want you guys to remember for tomorrow are nickel, iron, cobalt and steel. And these will always be attracted to a magnet no matter whether you put it to the North Pole or to the South Pole. And non-magnetic materials like gold, aluminium, copper and so on, they don't get attracted to magnets. Now there are two main types of magnets. They are permanent and induced magnets. And permanent magnets produce their own magnetic field, so they never lose their magnetism. Whereas induced magnets are when those magnetic materials that we spoke about before are placed into a magnetic field, they can create their own magnetic field for a short while, and so they're magnetic, they're induced magnets. So imagine, if you will, if I have a permanent magnet over here, and I take a piece of nickel, for example, and I put it next to this magnet. Remember, that's a permanent magnet, and this is going to be an induced magnet. Now, because I have the South Pole over here, what's going to happen to this nickel is it's going to get attracted to this South Pole, because it doesn't matter which pole is there, it's going to get attracted either way. And this bit of this nickel, which is attracted to this permanent magnet, will become the North Pole. So of course the other side of the nickel is going to be the South Pole. And this is now an induced magnet, so it has magnetic field lines of its own, just like the bar magnet. But this induced magnet is only induced because of this permanent magnet. So when this permanent magnet goes away, so does the magnetism of this induced magnet. And obviously you guys also need to be able to draw the magnetic field lines around the bar magnet. And just remember that these magnetic field lines show us the region where a force will act on another magnetic material or a magnet. Two rules to remember: magnetic field lines never cross one another, and they always point in the direction north to south. And this is what you guys should draw if you're asked to draw the magnetic field lines around a bar magnet. Notice that there are areas where the lines are closer to one another. That signifies a stronger magnetic field. And where the lines are more spaced out, the magnetic field is weaker. And you guys probably already know this, but opposite poles attract and same poles repel. So north to south attract and perhaps south to south repel.